Good morning, everyone. My name is Mirsad Shah, and I will be the presenter and host for this presentation here today. I obtained my bachelor's in electrical engineering from DHS of University, and my area of expertise include renewable energy and electrical machines. So if you have any problem or any query regarding this paper and this presentation, you can feel free to contact me on my email address given below. So let's get started with the title, and the title is Energy Harvesting Using Kinetic Energy of Vehicles. So what we will be doing in this paper is we will be extracting or harnessing the electrical energy of vehicles through some electromechanical device. Okay, let's go on to the co-authors of this paper, and he's Dr. Gasim Alandjani. He is currently working as a senior faculty member at Yanbu University College Kingdom of Saudi Arabia. He has a 28 years experience of teaching and research in different aspects of careers. The other second author of this paper is Miss Maryam Asghar. She received her bachelor's in electrical engineering from DHS Sufa University as well, and she graduated with honors. Her research interests also include renewable energy systems and their control using power electronic devices. So, if you want any info regarding this paper, you can contact her as well. So let's get started. This is just a quick overview of what's about to come, and we will have an introduction, a literature review, a research design as to how an road power generation unit really works, and finally some construction flowchart, hardware, some problems that we faced during our design of the road power generation device, and conclusions and references. So let's get you introduced with what energy harvesting using kinetic energy really is. So basically, imagine you're driving on a road and it goes night. It's night, and there are no lights, so you cannot navigate your way through. And we've all been there, and it's a bummer. So what we do is we can employ other sources of electrical energy on the road, and that will help in restoring the electricity on that particular highway or on that particular road. So one of those solutions is this paper addresses that problem. So street lighting is one of the five major consumers of power sector, and in a survey we found out that um, it accounts for about 14% of the global energy demand. So the aim of this paper is the global transition to green sources of energy, or the renewable energy sources. So, as it already suggests, this paper or this project can significantly contribute in energy production. You can employ this unit, the road power generation unit. What I mean by road power generation unit, we will be discussing later on. But you can employ this on any road, and this will produce electricity in up to many kilowatts. So, what is an electro RPG unit? So, RPG unit is an electromechanical device which produces electricity when a vehicle inserts kinetic energy into it. In layman's term, when a vehicle moves over the RPG unit or this device, it produces electrical energy and saves it in a battery. So, what other forms of energy can we employ on a road? So, we have road power generation by piezoelectric material. We've all discussed, we've all know about it in detail, but just to give you a quick overview as to how it may fail RPG by piezoelectric material. So crystals of the piezoelectric material prone to crack if overstressed, and the piezoelectric material behaves abnormally on different high temperatures. Finally, the second type of road power generation is RPG by speed breakers. Now, you may have heard of this before, RPG by speed breaker mechanism. RPG by speed breaker mechanism is a type where the potential energy of the vehicle is harnessed. So basically, when a vehicle moves over a speed breaker, the potential energy is captured and electricity is produced. But there are some problems associated with it. The springs in the RPG unit are not reliable, in the sense that if too much pressure is applied, the spring can deform. If a truck moves over the RPG unit, it just may deform and not restore its original position. And on the other hand, if a motorbike or a cyclist moves over the RPG unit, the unit may not produce any electricity at all, and you will be left with less electricity generation. So what can we do? Another type that we will be discussing in this literature review is the road power generation by harnessing the wasted energy of vehicles. This is a recent advancement that is being done in the road power generation sector. And what happens is that the heat energy of the tires, or the friction employed by the tires, is being captured in this type of road power generation, and as a result electricity is produced. But the setup cost of this is very high, since it is in the earlier stages of of the deployment. It is not accessible, and it has a very high maintenance cost. So what is the research design of this project? First, we need to understand what a RPG unit really does. It converts the energy, the kinetic energy of the tires of the vehicle, basically, into electrical energy. So as the tires move on the road, they will be inducing linear motion or rectilinear motion in the device. So as a result, we will be having a linear motion, and we have to convert that linear motion to rotary motion, just so we can feed that motion to the generator and produce electricity. So linear to rotary motion can be converted through many methods, but we will be discussing some here that we tried, and which one of those was successful, we will be discussing them in details. So first off, we have the crankshaft mechanism. So basically, we have a crank that moves to and fro, and as a result rotary motion is produced. So if you look at it, it's great. You can get maximum output uh, in 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 less input. For example, a car moves on the road, and it induces electrical energy or kinetic energy, beg your pardon, in the device, and you will have rotational motion in the crankshaft after the crankshaft mechanism. But what's the problem with this is that the crankshaft is really difficult to make. The crankshaft mechanism can damage the bearings of the pinions, and the flip plate that is being supported by the crank can be unbalanced, and you can basically put millions of lives in danger if you are employing something like that in big capacity. So what we did was we used the rack and pinion mechanism. Although this mechanism cost us 50% of the efficiency, what I mean by that is pretty simple. First, let's understand what a rack and a pinion really is. A pinion is a circular gear that engages its teeth on a rack, a linear bar. I can give you a quick look at what it really is. So a rack and pinion looks something like this. The rack moves, or the pinion rather, when moves on the rack, rotary motion induces linear motion in the system. And if the rack moves on the pinion, linear motion induces rotary motion. It's basically vice versa. So if you want to convert linear motion to rotary motion, you can use something like this. But the main problem is how can you use that stroke, that circular motion of the rack, and hold it where it was, the position of the flip plate. So what we do is, I have discussed this extensively in my paper, do check and read it out, but I'm giving you a quick intro as to what it may be. So what we do is we put a flip plate on the top of the device, and this device is held by racks. So racks are holding the flip plates, and when a car moves over it, the racks or the flip plate basically moves to and fro. And what you will observe is, with that linear motion, the pinions below the racks will be moving in circular direction, and you can harness that energy, or you can feed that energy to generators or other devices which you may use. So the only disadvantage that the rack and pinion mechanism has is that it only uses the half stroke of the rack. So how did we do that was by employing clutch bearings on the center of the pinions. So if you have 3 pinions and all the pinions are supported by a shaft, all 3 will have clutch bearings employed at the center of the pinion. And as you already may know that multiple pinions will increase the efficiency, so 3 pinions were chosen for this task. So the construction of this RPG unit is pretty simple. As I told earlier, you'll have a rack on the top. You'll have a flip plate on the top, the rack on its bottom, and a pinion that will move through the shaft, and it will induce rotary motion in the chain sprocket system. And finally, that motion will be converted into electrical energy via a generator, and the observation of electricity can be done via a charge controller. So the construction of a flip plate is shown below. The flip plate is the main crux of this project. So if you want to build a flip plate, you have to know it would look something like this. So what is a flip plate? A flip plate is basically a metal sheet that has been, a rectangular metal sheet that has been cut in a specific device. If you can look at it closely, we have a flip plate A, that is the flip plate on the top, and then we have a flip plate B, that is the flip plate at the middle, and then we have a flip plate C at the bottom. What the different different markings A1, B1, C1 and D1 really mean is that to stop the center mid flip plate from moving freely, we have employed springs to hold the positions of A1 and A2, and then another spring from B1 to B2, and another spring from C1 to C2, and finally another spring from D1 to D2. And as a result, we can see that our flip plate will be joined at one end, and when the car will move over it, it will basically be opposing the elastic potential energy of the spring, and as a result you will be harnessing the energy from the device and using it for your electricity output. This is basically the flowchart of the RPG working unit. And when the car moves on the flip plate, kinetic energy from vehicles causes rotational energy via rack and pinion. As we discussed earlier, the rack and pinion mechanism converts linear motion or rectilinear motion into rotary motion. Finally, the RPM of the shaft, the upper shaft, the shaft holding the pinions, increases. The chain sprocket system induces the rotary motion in the shaft below, or the shaft 2. So the angular energy is now shifted to the shaft 2. Finally, the flywheel stores the rotational energy temporarily and then releases it in sudden amount for the PMDC generator to convert it into electrical energy. Finally, we have a buck boost converter to stabilize our voltage, and finally we have a charging system for our battery to charge. This is basically an example of how the rack was really made. On the right hand side we have the actual rack. The next up is the pinion. On the left hand side is the AutoCAD for the pinion, and the right hand side was the actual pinion and how it looked like. This was the chain sprocket system that we used. You can use any system that a cyclist may use in his gear bike system, so don't worry about it, you can easily get it. What were the problems faced in this paper or this project? One of the problems that we faced was the designing of the rack and pinion mechanism. We used a crankshaft mechanism at first to transfer linear motion to rotary motion, but it was really difficult for us to make something like that in that project. So what we did was we used the rack and pinion mechanism. Note that if you can use crankshaft mechanism, you will be doubling the electricity production of this project. Basically, you will be increasing your production output by 200%. So what we did was we designed the rack and pinion mechanism, and it saved us a lot of time. The next problem that we faced was the frame. How can we build the frame that all of this can hold on to? So we used high tensile material. We put on modeling techniques into it, and finally came up with the right model to make the flip plate being supported perfectly on the model, on the frame rather. So an electromechanical system was designed and implemented in this paper. The results are shown below. As you can see, we did not have a lot of things to work with. So what we did was we changed the spring constant of the spring that the flip plate was holding. So when we increased the spring constant, when we increased the spring constant, we noticed that the power that was being produced by the device increased a lot. So if you decide to use the spring constant with a higher value, that may also cause you a bit of problem. For example, you employ a truck, as we discussed earlier, that may easily power it, but if you use a bike, that may conjure some dangers to the person using that device. So it is recommended to put the spring constant somewhere near 1133 to 1278. We tested it and it was pretty safe for you to use. Another thing that power production is I'm sorry. Another thing that the power production is worked upon is the coupling. Is the spring constant. Finally, we have the references for this paper. All of this was a novel work being done by us, so feel free to read it, give it a read on my ORCID ID, or you can check on my author's ORCID IDs. The link is already given in the description below. Feel free to ask us questions that you may ask regarding this project. We will be hoping to hear from you soon. Thank you. Allah Hafiz.